Assalamu alaikum and welcome to part 2 for chapter number 8, characters and strings. And today we are actually going to discuss 2 to 3 different topics from again chapter number 8. This is going to be the part 2. In the last part, we discussed how strings and characters are going to be declared as an array, as a pointer to a string in a memory, or how you are going to actually take on the functions which are having the characters as an input. That was the is alphabet, is number, and all that. For that purpose, just scrolling through all these ones, that was the is alpha, is digit, is x digit, or similar kind of functions that were there inside the ctype.h library. Today, the functions which we are going to discuss are mostly related to the std.library.h, and these functions are for those conversions. Remember, this topic is the string conversion functions, and this is for those functions, for those strings which have some numeric value and some text inside it. What I mean by this, for example, I have some text inside, stored inside some pointer string, and that is supposedly something like this, as shown over there. That is 51.2% are admitted. So supposedly this is a string added over there, and out of this thing, you actually want to take out only the number, or actually the digits over there, which is 51.2. Now, since this is a decimal value, so of course you need some float or double. So the functions which are available for this purpose are called as str2d, and then str2l or str2ul. Now, the names are self-explanatory, nothing too fancy about it. This is str2d, and d here stands for double. So the function return type is double over there. I will come with the parameters a little later on. And then I have the next function, which is called as the str2l. L here stands for long. So that's why it's the long int over there, which is actually going to be the output over there. And then afterwards, you have the str2ul, which is unsigned long. Ul stands for unsigned long. So the return type is unsigned long. Now, all of these three functions which are available can be used. Supposedly, you have a number inside a string which is stored inside some memory or maybe inside some file as well. But since we have not gone through the file, which is actually chapter number 11 in our case, we will come back to it and we will use these functions again when we are talking about chapter number 11. But at present, since supposedly the first function which I'm talking about is this str2d, which has a return type double. So over here, you can see the first input of the parameter is const character and pointer and ptr. Now, the first thing which comes into why it's const. Actually, it's const because the function is going to take that string pointer, because string is going to be stored inside a pointer. That pointer is some string to inside the memory. So it's going to be a pointer. So that's why it's a pointer. And the word const is used because I don't want, or the function does not want to change the original string pointer over there. It does only wants to take that numbers from it and don't alter anything. So it does not want to change anything inside that pointer data, or the data it's pointing by the pointer over there. So it's having a cost. Then next thing, that is character, and then there is pointer and ptr. Now here, this is something a little confusing. Now let me give this a very simple explanation to you. Now, when this function is going to be called, the output of this function is going to be double, which means it's going to take out this 51.2 from this whole string statement. Well and good, that will be output over there. But at the very same time, this function also tells you that what is the remaining data apart from that number over there, which means that when this string is going to be admitted to this function, in place of this first parameter, the second parameter is actually going to be a pointer to a pointer over here. So these two hysterics are actually going to change the pointer to a pointer. Now, why this is a pointer to a pointer? Why? Because here you are adding a pointer to that string which is stored inside the memory. So this thing is actually a pointer to that pointer where this is going to be stored, and it's going to tell you that what is the remaining. Let me just again rephrase it. What is going to happen? This 51.2% are admitted is a string stored inside the memory. And if you call this string pointer, it's going to be initially pointing to 5, which is the first one. But when this function will be called off by whatever parameters inside, 51.2 will be copied and given to a variable, because the return type is double over there, and 51.2 will be stored inside that double variable. But at the very same time, the remaining text, which is percentage space r space admitted, is the remaining string. And we don't want it, but sometimes we need to find out that that text is also there. So this second parameter is that pointer to that string pointer, That's why there are two asterisks over there. So this particular pointer, which is going to be a pointer to a string pointer, which is this string over there. So this particular pointer will be pointing to this percentage 1. Remember, this is a character, so only one is going to be admitted at that time. So this is going to be pointing to that percentage. So when this function, now supposingly it was not 51.2% are admitted, the answer was supposingly 51.2345. Let's supposingly. So then at that case, the second parameter is actually a pointer. And in this function, you can't have two returns. Only one return is there, which is double, and that is going to be returned. That will be 51.2, or in our next case, which I'm talking about, that will be 51.2324, something like that. But the second parameter, which is a pointer to that string pointer, that will be returned to this data over here. And the first thing in this data is the percentage sign. So percentage space r space admitted is going to be pointed over there. That is the percentage sign will be admitted. Now, just to give you an idea, before I go on, in the slides over there, let me just go on the slides over there. I'm at 20 slides at present. So string conversion function, this is stdio.h. The function is strtod, and inside the parameters, I will just discuss the parameter just now. It converts to double. Then I have string to L, which converts it into a long int over there. Then I have string to unsigned long, which means unsigned long int over there. So I have three functions. If I want to convert something in decimal values, then you have to use the first function. If you have something, a very large integer value that may be there inside your file or maybe inside your string over there, then you can use the second function. And if you have something very, very big, supposedly maybe a date converted into something, an integer value, supposedly, let's say, I will talk about this later on, and maybe in chapter number 11 in detail. But and then that case, then you have to use this function. And your function parameter is going to be something like this. Now, remember this thing again. You have a double is the return type. Str2d is the function name, brackets open, const character asterisk str. This is pointing out to that string pointer which you want to actually take the data out, which has some numbers, some alphabet, some everything inside it. So you want to take out some data, and here that is 51.2 is the data which you want over here to be converted into that double. The second parameter is that character pointer, which is pointing to another pointer, and that pointer is actually this pointer over there, which is pointing to the string over there. So don't confuse yourself with these two pointers over there. These two pointers are pointing to the first character after the number. So this is going to point out. So when this function will complete, this end ptr word is actually going to point to this location of this percentage. And then if you want to print it, you have to just give in your printf statement percentage s, and you have to write down end ptr, and it automatically, because that's a pointer. Remember, end ptr is a pointer to a pointer of string. So this is going to be the function. Now, before showing you the function here in front over there, before we go to the other function over there, let me just show you the example which is over there. Now, let me just go through directly to that example. This is the example over there. stdlibrary.h is the added over there. Const is added just in case. If you don't want to use the const, I can just take off it. Totally up to you. just in case I don't want that thing to be changed over there. Now, character static string is equal to 51%.2 are admitted is that string. The pointer to this string is the name string. And then I'm creating a pointer that is initialized to null. Now, even if you don't initialize it to null, no issues. Why? Because this is going to just go as a parameter inside this function when it is going to be called with the and symbol. Why? Because you don't give that string pointer, you give the and symbol, the location of that pointer. So that is going to be the location of pointer, and that location of pointer is going to then point to the data where this percentage are admitted is going to be there. So when this function is going to be called, the function is very simple. Double D equal to, double D means that D is a double data bucket type. So 51.2 will be inside D, and str2d is the function called. And then I have the string, and then you have the and symbol, string ptr. Remember, don't miss the and symbol, because and is actually going to give you the location of that string ptr. And inside that location of that string ptr, because this is a pointer to a pointer, so string ptr is a pointer. It is going to store the location of another pointer inside it. And that location is that percentage sign, because after this percentage sign, you can have the whole whatever the remaining string is remaining over there. So inside the printf statement, if you just see the first printf statement over there, the first printf statement is the string. Then you have the inverted commas over there. Remember, I hope so you remember it, that if you want to have the inverted commas written, then you can use this with the backslash inverted commas and then percentage s, because you want to have the string printed, and that is the string, this string. So you are printing the string is converted to the string over there. So you are actually converting the string is converted to the, so the first string, this is 51.2% R is converted, is being written over there. So without any conversion, I'm just writing down in line number 12 over there. You are just writing down this whole string over there. And in the next line, on line number 14 over here, in this case, that the double value percentage .2f and the string over there. And here you are putting on D, and you are here having string ptr. So you can see over here that double value percentage .2f. So here in place of this thing, 51.2. Now already this is 2 over there. Let's say if I have it something like 58.2, 3, 4, 5, 6, something like this. So it will automatically be truncated to 2 decimal places, because this is .2f over there. And the string, this is percentage s, and then inverted commas inside inverted commas, and then backslash n. So this will be D will be printed in place of this, and string ptr. And what is string ptr? String ptr has the location of the pointer to the remaining text, which is percentage are admitted over there. So when I'm going to run this command now, let's see what happens. When I run this command over there, you can see now the string with inverted commas is this, because this was my string 51.234367 are admitted inside inverted commas. You can see the inverted commas. I have added this space over there. That's why it's actually adding that space over there. If I run it again, that space with the inverted commas is converted to D. The double value is 51.23. You can see it has truncated the remaining values. Now, if I don't want to truncate it, let's say I just want to add the whole digit. So I will just run it again. You can see now the whole value 51.234367 or 4637, and the string percentage are admitted are here. Now, even if I had something and something over here after this one, I had supposedly my name over there, added over there, and it will still miss the statement. And you can see this is separated. So this is a very, very simple function to actually take out the text over there. And remember one thing, it only gives you this string ptr after the digit. Supposingly this Arslan Rahim, supposingly, let's say if this was not added over here and this was added somewhat here, now let's see what happens. Now you can see you have 0.000. You have no value. Why? Because inside that string, the first thing is a text, a string. So this string is not converted, is never converted, it's 0.00. So only if your string is starting with a number, then this thing works over there. Otherwise, this thing is not working. And supposingly, let's say if it is admitted over there, and afterwards, let's say I have added something 45.2 percentage is not admitted. So I have added now two string literals, two alpha, sorry, two digits over there. So if I just do it again over there, you can see now the only thing is the first number. So only this is cat. This one is not caught. So this is one way. So this is in which way you can only getting, and remaining one is the same. So this function has some limitations that you have to have the number which you want to convert it into. So this is actually just a function to convert a string into a double or a number or an integer or something you can call it. Not an integer actually. This is actually a float or a double actually over here in this case. So here this is double because this is 51.23467, and you can now even change it to, let's say if you want to change it to 0.3 just for the case of it, then you can have it. So this is actually 51.235 because this is 51.23 and this is rounded off. So I hope you are getting this point. So this is the function, and this function works for any string which is starting from a number and works for. So this is the double pointer over there. So a pointer to a pointer. Why? Because strings are always accessed by pointers. So you need a double pointer over there. And that pointer then is pointed out to the remaining text inside that string. That's all. The next function, which is called as string to long integer. Now here, this is an integer, and there is a third parameter over there, which is a little different from the previous one. Here, this is int base. Now, why base? I hope you already are familiar with the number system. They are binary numbers, they are hexadecimal numbers, they are octal numbers, they are decimal numbers. So if your number is going to be, you have to tell the compiler or this function that your number is of which base. So if you are processing supposedly binary, then you have to tell it 2 over there. If you are processing hexadecimal number, you have to tell 7 over there. Actually, you have to tell it 8 over there. If you are talking about the decimal number system, then you have to give 10 over there. If you have a hexadecimal number, then it's going to be. So it's going to convert that number based on that base and give you the percentage D. Remember, this is going to give you the percentage D or percentage LD, which is actually the long int over there. And for that purpose, the example here in front of you is this thing. And you can see over there, now this time the string is minus 1, 2, 3, 4, 5, 6, 7. It is not having any decimal number. So this is minus 1, 2, 3, 4, 5, 6, 7, ABC. And here, then again, a pointer is created, and you can name that pointer anything, totally up to you, X, Y, Z, ABC, whatever. Totally up to you. If you don't want to make it to null, totally up to you. You can do that. But remember, don't miss this and symbol, because the and symbol actually makes it that you are pointing out to the pointer to a pointer. So this is going to be over here. So here, the variable now, because the function is going to return a long type, return type. So long x is equal to strtoul, and then you have the string comma and remainder ptr comma 0 over there. So you have long x equal to strtoul over there. And then you have now the function to be printed, that is actually printf over there. And you can see inside this printf. Now, don't get confused because of this long percentage s and percentage LD and all that stuff over there. This is completely okay. You can see, first of all, what is this? The original string is. So that's why there is percentage s. Totally up to you. Okay. Then you have the inverted commas with backslash inverted commas. So that's why this means that the converted, this string is going to be inside inverted commas. And what is that string? Which is this thing. So, and then afterwards with this percentage s, this will be the string. And then afterwards again, you have the inverted commas close because you want to do it. And then you have backslash n. So the first line is complete. And that's why the printf first line is complete. Then afterwards, the next thing again, then it's percentage s. Then afterwards, the percentage s, then this is the x. What is x? X is the data bucket long. And for that long, you have LD. Up till now, for integers, you have been using D. For long, the format specifier is percentage LD. So you have the LD over there. And then afterwards, you have the %n for the next line. And then you have the third line over there. And that third line, you have again %s, then again inverted commas. And the remainder of the original string is again remainder PTR, because remainder PTR, you can see Visual Studio Code is telling me it's a pointer over there. And here you are actually going to tell it again \n after this %s, and then afterwards you have the converted value plus 567, because now you are doing some mathematics over there, x plus 567, because x is now a number. This is a very good way of taking out a number from a string, but the condition is it has to be the first thing inside your string, which means the first position of your string pointer, it has to be inside it. You can't have like something like that let me just run it first and then I will do some changes inside it. So if I do some changes over there, oh, sorry about it, whenever I select something, that bulb comes in, as you can see now. So this is the converted value plus 567 is, so if you convert this thing and you add the 567, so that becomes -123, because it's negative value. So this is -1 2 3 4 5 6 7, so 567 is added, so that becomes 000. So otherwise this is something. Now one change I can do, just to give you that this is not going to give answer, if I add this ABC minus this thing over there in the start, so this function is not going to be anything. So it's not going to give any answer. Why? Because the first letter or the first thing inside your string, or the pointer to the first element of your string, has to be that number. If it is some alphabets or something else, then it's not going to be there. So it has to be some positive or negative number to make this function work. And here this is 0. So 0 means over there, as per the slide also, 0 means auto detect to any values over there. And here you can put, instead of this third argument, any value from 0 to 2 to 236. 1 is not included, remember, 1, because number system cannot work on that one. 0 means auto detect. It's already going to detect that whatever is going to be. So because hexadecimal numbers can also be there. So hexadecimal number means from 0 to 9 and from A to F over there. So they can also be there. For example, let's say if I have a number, let's say I have a number over there. If I change this thing, let's say I have some number instead of that negative value, and afterwards this thing, and I have afterwards A, B, C. These are hexadecimal number, and then I have dot P and etc., whatever stuff. Now, if here instead of 0, now I will put 16, this is going to process it as a hexadecimal number. So it is not just going to take 1, 2, 3, 4, 5, 6, 7. It's also going to take ABC, take it as a hexadecimal number, convert this hexadecimal number into its decimal, because LD or long int is a decimal number. So when I'm going to process it, sorry, again, I have selected it, and that's why it's going to give me an error. So when I run it, you can see now the original string is this thing, but when it is converted, this is converted value. And you can go on Google, do on some calculator. This hexadecimal number 1, 2, 3, 4, 5, 6, 7, ABC is the hexadecimal number. Converted into its decimal equivalent, you will find out this answer which I have highlighted, which is 78187494076 over there. And you add 567 into it, then this is the answer over there. So I hope this function is clear to you. The only thing different in this one is that you are having a base being added, and this is something very good whenever you are taking some data from the file and it has some hexadecimal number or any number system over there. Normally, the number system you already inquire is the binary number or the uh, hexadecimal number or the octal number over there, but normally it can have up till 36 number. Normally, we don't use those decimal number, system number systems over there, which has like 20 digits inside it, or 21 or 22, but it has the option that you can change its base over here by using this one. So this is a string to long integer. And similarly, based on the exact same nomenclature, the next function, which is string to unsigned long, which is the return type is unsigned long, remaining things remains exactly the same. Remaining things remains exactly the same. This is not going to have a negative number. So if you are, let's just say, if I want to change it to, let's just say this is going to be strul over there. And now this time, if I have just a positive number over there, so let me just add, I can have an unsigned, unsigned long over there. And if I just run it, So this will still run. But now if I add a negative sign, so I hope so this will be giving me an error, or this is not going to be processed over there. So this is going to be, in fact, let me just see or not. I have an example of unsigned long. Yes, I have an unsigned long over here. Example. So if I have this unsigned long, so it's not going to take that thing over there. So it's going to be an unsigned long over there, and you can add or subtract or whatever in this thing inside this unsigned long over there. So these are three functions inside std.library.h. Play with this thing. It converts into unsigned long and positive numbers only. Remember, only for positive number, not for negative number. If it takes that negative number, that sign is going to be not used over there. So you have this function that is str to ul. You have a function str to l. You have a function str to d. Again, this is only when the first character of the string is a number, a digit, or something, then these three functions are workable. Then some questions over there from your book. What would a function parameter be? Character, which is star star. Star star here means that it is a pointer to modify a character pointer. It's a pointer to a pointer. Same thing I have told you, that it's a pointer to a pointer, because inside the function, you only have one return type. The return type is already there, either a double or a long or an unsigned long. So you have to have this static, which is actually a pointer to a pointer. So the definition of the function, it is having that double statics over there. Next thing, a small question over there. Which statement about str to L is false. Return 0 if unable to convert. No, it does not return. Yes, it returns 0. Yes, it's totally true. Yes, it's true. Takes 3 arguments. Yes, it takes, because it takes a string, it takes a pointer, it takes a base. Ignores the leading white space. No, I don't think so. Use characters to return the numeric value. That's wrong. It does not return numeric value using this thing. It returns using the long return time over there. So let's see what is the answer over there. I hope I am right over there. Yes, I'm right over there. The D is false over there, which is that uses the character to return numeric value. This is wrong. So it also ignores the white letter spaces. It's true. It takes 3 arguments. You already know. It returns 0 if unable to convert. That's also true. So this uses to return location after conversion, not the number. So character static is a pointer to a pointer, which is being given as an AND function or AND symbol over there inside your library or whatever you are. So this AND is actually giving a pointer. So it's updating the location of a pointer, which is a pointer to a string. So when this function is run, previously it was null. Previously this was null pointing to null. After this function is run, then remainder PTR, it points to this location of ABC. So this is just all for this std library.h over there. And if I go on over there now, some more functions which are inside the standard library, which we have used up till now, stdio.h. For these, you don't need to change anything. You don't need to add another library. Now, what are these functions? These functions are a little more than what you have used up till now. Now, up till now, you have been using Scanf and all that. In fact, in this part, I will tell you the issue that was in part number 1, that I told you that was the issue with Scanf. That is actually an issue with Scanf. It does not take one parameter. I will tell you what is the solution of that Scanf also here by using this one. Now, supposingly, you want to read one character. Supposingly, you just want to read one character from the user. You have asked user to use scanf and it enters instead of one character, it just takes like 2, 3, 4 digits or alphabets or whatever. But you only want one character, so read one characters from the keyboard. For that purpose, you have the get character function. Then you have put character. Now this is printing one character only, and this takes the character as a parameter. In this function, you're not going to put an array or something like that. You're just going to put maybe one array value over there, one array location over there. Then it can be printed if it's a character array, or otherwise just a simple character. Then the third function. Now that third function is something very, very important. And that is, up till now, there's a solution for that scanf problem. And what is that? Here the function is called as fgets. And inside it, you have s, then you have n, and then you have stdir. stdin is the standard input library. It's just a stream over there. We will talk about this one in chapter number 11. At present, just fix it to stdin. I'm not going to change that one. Then S is that array where you are going to store that string. Previously, in the last lecture, I was telling you that you are going to store it inside a character array, but it was not going to take that data. So for that purpose, here I have fgets. It will automatically read the string, store it inside that S over there, and N is the length of that array, which the character array in which the string is going to be stored, and it is going to store up till n-1 because the last value is going to be the null terminator. I will just go through this example just one by one, so don't worry on that one. Then puts, we have already used this puts up till now. If you remember your chapter number 3 or chapter number 4, we have used this puts a lot. Puts is just like printf. The only thing is it prints the string plus the new line. That's all. It prints that whatever you are going to put inside it, a string, variable, or whatever, and it's printed with a new line added. So it does press the enter already. Then up till now, you have been printf, you have been using scanf. Now introducing with s subscript added inside the statement, you have been using printf up till now. Now this is sprintf. Here, this is print formatted to string inside an array. Now here you are printing it to an array. Remember, instead of printing on the screen, you are printing it to an array. So this is sprintf. The array name is scanf. This is going to store inside the array over there. So this is going to be reading the formatting string from string. This is also going to read or print formatted to the string over there. So let's go one by one on all these functions over there. And first thing, which is going to be a lifesaver for you, because now you can use this instead of your scanf, you can now use this fgets over there. And before I discuss this one over there, let's just go on the example over there. And here inside this one, you can see very easily over there, what is this function? Now, what is this function? You can see over there, I have a function prototype on the top. And what does this do? You can see over there, it's a void reverse const, which means it's going to take a constant data inside it. And it's a pointer, of course, a pointer required by, because it's going to be a string to be added inside it. So it's going to be a over there. The return type is void, so it's not going to return anything. It's just going to print something. I will just show you this one. And this is a constant SPTR. So this is that case 4, if you remember from your chapter number 7. It has a constant pointer also and a constant. So that data, which is that pointer, is going to be pound, it's also going to be constant. So this is the function prototype. And inside the main function, what is happening over there? I have a character array of name sentence. The size is 80. And it has been initialized as empty, just with 2 inverted commas, nothing inside, it's empty. So the size is made inside your RAM or memory, and it's empty. Then afterwards, puts, enter a line of text, simple, and puts, inverted commas, it just put, enter the line over there. And now you are using the fgets. Now fgets, and inside fgets, the first parameter is sentence. What is sentence? The array, the character array, which you are going to put inside. Then size, you have to tell the size, because you need to know how many items you want to store. So size is 80, so this means 79 is going to be stored. And stdin is going to be the reserve word already there, always is going to be there. So it's going to be the standard input. In here stands for the input, std here stands for the standard. So this is the standard input library being added. So this line will read a line of text taking from the input keyboard over there, whoever is typing over there. And then afterwards, when this is done, then afterwards printing f percentage n, and you have S over there. Then you have the line printed backward is, which means afterwards this function is called. So whatever you are going to write down, it's going to be reversed. And then afterwards, just a simple puts over there, just to put that backslash n. You can put a backslash n even here by using printf over there. But the real thing over here, which is happening, is inside the line number 12, which is going to read a line of text by using this one up till now. And the function. Now, this is a recursive function. Now, this is something very, very carefully. You have to see this very carefully. It recursively outputs characters in a string in the reverse order. So it's going to take that string pointer, which is coming on from this thing. And here that is the sentence, because sentence is a array of characters. So you don't need to add the and symbol inside it, because array all and pointer, they both are exactly same thing. So when you are calling that reverse function with that sentence, so it's already going to be there. This is the base case. And what is the base case? Because every string or every character array, when it is going to point out to a string, the end case is going to be the null terminator. So if the null terminator is there, then this means it's going to be written. It's going to be written. Nothing has to be printed. But if that is not the case, then the recursion case, if not the end of the string, then call the main function again, and this time do it with and ptr1. Now, this is something very important. That is and sptr1. Now, what is happening? You called this function reverse by using sptr. Here, sentence is and sptr. They both are exactly the same thing, because when you come inside the function, sptr is actually the name. So, sptr, when you are calling again that function, you are actually calling it the function, but again, now this time with an increment of value. That is sptr1. When it will be called again, the function will be called again. It will go back here, go through the base case. If there is some text inside it, it will not go through the base case. Again, come in over there, and again that function will be called. And this time, again, the function will be called with an incremented. Every time this function is called, the pointer is pointing out to the 0 location. But it again calls itself the same function and goes on +1, which means this is 1 every time. So this is the recursion step, and this will go on up till it starts to return from the base case, which means it encounters a null terminating over there. Then if that happens, the null terminator is found out, then you have a put character over there, and that put character is going to print it. And that put character is exactly the same function which I just told you. That was this put character. This is put character that prints the one character over there. It's going to print because each character is inside that string. So that put character term is going to print it over here, this thing. So let me just again explain this thing, because this is a little tricky over there, because you can see and don't understand this one over there. When this function is called, sentence, whatever that value of sentence is inside it. Or in fact, let me just run it first. Let me just run it first, and then I can give you a more elaborate explanation on this one. Let's say I have put my name as Salam. I just print enter. The line printed backward, you can see my name is enter. So what happens over there? Now see this very carefully. When this function was called at this line number 15, Arsalan was inside this sentence array. A was at 0 location, R was at 1 location, S, and so on over there. The location is 80, but when it is complete, so this is there. Now, when this is happening, when this comes inside this function, it searches for the null terminator, not found. So it goes inside the else. At this present time, when this pointer is inside this function, it is pointing to A. Remember, it is pointing to A. It goes inside it, it finds out, okay, else statement, and then now reverse again function is called, but this time with the same pointer which was called as sptr0, because it was pointing out to the 0 location, which was A. So now this will be pointing out to R. So this function will be called with R. When this will be called with R, this will be again going inside the base case, still not true. It will go inside the else case, and this time now, it will now again point to S. So this is changing every time. So this one is actually, because whenever a function is called, that pointer is pointing out to the 0th location. And that 0th location is A, first of all, then R, then S, then A, then L, then A, then N. Up till the base case is there, that is whenever this null terminator is found, this will go on. When this is found and returned, then this function starts to return one after another. And when it starts to return, the last value to print would be the Arsalan n over there, and that will be put character SPTR over here. And that's why n will be printed first, then a will be printed, l will be printed, a will be printed, s will be printed, r will be, and then capital A will be printed. So I hope now you are getting the point that here the reversing of it is done by the recursion. I hope you've got the idea that recursion works in this way, that you call a function and then you again call a function. So now you are incrementing in your string pointer. So every time this line number 26 recursion step is being called, your SPTR is being increased over there. You're not putting plus plus sign or something like that. Here you are just going through, and is being added because and is the memory location of SPTR. So every time you have SPTR, the function is called, SPTR has SPTR 0. But then you go in the else statement and 1. So you call A, but here then you call R again, then you call S again, then you call A again, then you call L again, then you call A, then you call N, and then afterwards, okay, now the null terminator is there. So the SPTR goes on, it returns. Now when this returns, the previous function also returns. Then 7 times this function has been called, so it will return. And now when it starts returning, this line number 27 is going to be run how many times? 7 times, because Arslan has 1, 2, 3, 4, 5, 6, 7, 7 alphabets inside it. So 7 alphabets will be printed in reverse, because the last function which was called will be returned first. Then the first function which was called will be returned at the last. So that's why this function is printing it inside in reverse over there. I hope now you are getting the point what this fgets do, and this can do for any spaces even as well. Now let's see. I just want to show you. Every time I select it. Supposingly, let's say I am a teacher at UET Lahore. I have spaces inside it. I can in electrical department over there. You can see now this is printing in the reverse. So even if it has spaces over there, so it has no issues over there. Now coming to scanf. Now scanf has an issue. I told you in the part 1, I will tell you the solution. I hope those who have gone through part 1 can give me in the comments over there. For scanf, the problem is this. Let me just go through that case. The problem with scanf is this, in this statement, as you can see over there. In fact, let me just comment this statement. I will guess this is actually the solution for the spaces over there. Scanf has a problem that whenever you ask that scanf over there that you are going to take 9 string inputs over there and you're going to store in H, it does not take spaces as a character. So you have to tell the scanf that spaces or a new line has to be taken as an input. For that purpose, the solution is this, that instead of using this percentage 9s or something and storing inside H over there, let me just run it again and I will tell you what was the error. The error was it, here I'm actually asking to store something inside it. Let's say this was Arsalan is teaching at UET Lahore. So when you do it, you can see now only Arsalan is printed. Why? The space was there and it ignored it. Scanf does not take spaces inside. It thinks, okay, that is over, gone. It's not stored. For that purpose, the solution is some specifier, and that specifier you can see over here is written as this thing which I've highlighted, which is inside the rectangular braces. And here you can see this is that mark over there, which is just beside your on the 6th digit on your keyboard over there, the power mark, that is the power mark, and then backslash n. So until backslash n is going to be there, which means that is the enter is going to be pressed on your keyboard, it will still take that input over there. So let's just run it again now and let's see. Sorry, I've selected, whenever I select something, the compiler actually. So now Arsalan is a teacher at UT. You can see now it's storing. So this was a problem, and this is a problem inherent in scanf. It's not an issue with the coding. It is a problem with scanf. And for this purpose, I've given you the solution, and that solution I have told you is fgets, and that fgets is giving you, you're storing inside sentence. You are just telling the size as well over there. Now let's say instead of 80, I just give it 10 here, and I run this code. And let's say I have enter a line of text, Arslan is a teacher at UT. Now, of course, this is more than 10. I've gotten a more than 10. Now, let's see what happens. When I press enter, you can see what has happened. It only stored the first 10. The remaining is lost. This does not happen in Scanf. You can do this one. Repeat it, enter a long line of text, the array is small, and you enter a line of text, it will go on. And this will jeopardize your memory. And supposedly it goes on to another variable which is stored inside the memory, then you will have segmentation fault also at runtime. But fgets will not get you that error. So fgets also takes into control that what is the size, what is the variable or the array in which you are storing, and this reads a line of text. This stdin is coming in from this stdio. IO means input output, stdin means only input. So this is actually taking the input library in function. I will talk about this one when we are talking about the file structure in chapter number 11 in detail over there. Kindly go through this reverse function a lot. This is something very, very tricky, and to understand it, I hope you have got it. And if not got it, just scroll back and just see what is being happening over there. Another example, just to give you how this is working over there. Uh, just simple, if you want to have the get character, because I've not discussed the get character here. Here you can see over there, I have an int variable C. I have a character variable array, character array over there of size 80 again, and I have int I equal to 0. Now here inside it, I'm going to use get character to reach each character. And here what I have, while I is less than size minus 1, I is equal to 0. So I only need to enter characters one by one, and this will go on up till the either this is not true or C is equal to get character is not having an enter mark. So C is equal to get character is not equal to the carriage return, that is \n on the new line. And this will go on. And afterwards, remember one thing, when you have done this thing, you have to add the terminating string, the null terminator. If you don't do that, then when you are going to print this one by using the put statement, then this will be in problem over there, because the null terminator will then not be encountered over there. Let's just run this program and see what happens. Again, sorry, I have selected, and whenever I select it, and it gives an error. So now you have enter a line of text. So supposedly I have Arsalan is a teacher at UET Lahore. You can see it's still less than 80. That's why it's taking it. If I reduce it, then you can have a little thing. Now you can see over there, the line enter was this, and this is taking. Now here inside it, let's say I want to change it to, let's say 10. And now again, I run it. Now let's see what happens. Arsalan is a teacher at UET. So this means I'm now putting more than 10. So let's see what happens. Only stores the first 10. The remaining is gone. Will this while loop will take the input every time it's taking the input, but only the first 10 digits, because this condition is I is less than 7, size minus 1 is going to be true only that time. So it's going to take characters from the input. So even if you type on like 100 lines, 200 lines, still only the first 10 digits or the first 9 digits actually will be there. Why? Because 9, because size minus 1, the last one has to be with the terminating string. Now, if you don't take that terminating string, let's say if you don't add that terminating string over there, that is the null operator over there. And now this time, let's say I have added just my name, add over there. It still works on over there because it still works. But again, now one thing very important. Now I'm going to give you a little. Aslan is a teacher at UET. Again, something happened. Now, why this is not bothering you? Because I'm not adding it. Now, terminating string is not bothering you because this code has only as like 2 or 3 lines or 4 lines over there. But when you will have like 5 or 6 different variables, a lot of compiler variables will be there, then this variable, which is called as sentence, which is inside an array, which is actually an array, this will jeopardize with, because it does not have a null terminator. Then you will have segmentation fault. So you may or may not have segmentation fault depending upon the use of your variables and where your compiler has placed those variables inside memory. So inside your memory, so this null terminator or terminating string is a requirement for your memory, because when the puts is going to be, and if you have some other variables just beside this sentence, an I or C or some other variables XYZ, then this will cause a problem. So this is something very, very important, that you add this terminate string character at the end of the last, after this I has reached to the last size point, which is size over there, which is in this case is 10, or previously it was 80 over there. So this is the get character and the put character and the fgets thing, which is very, very important. And these three libraries are something very, or these functions are very, very important. And I guess now, from now on, you won't be using the scanf unless and until you are trying to take some integer input from the user or something number over there. If you are going to take a string input, now you are always going to take that fgets over there inside a string over there. So that's why this chapter is about strings and about the characters over there. Puts we have already digested now. The last two over here, let me just go through some example over there. In fact, let me just go through the slides over there. So fgets, it stops at the new line or the end of file. End of file means because we are going to take this function for chapter number 11 also. We will talk about this end of file also again. So it includes a new line in the string, adds this one, that is the null terminator, automatically. So it uses the stdion, that is the library for keyboard input, that is actually the file stream over there. Here, instead of in chapter number 11, you will be adding the file name or file stream over there. So we'll talk about it that at present, just fix it for stdin over there. Same thing in the fget statement, we have just done the example over there. Then get character and put character, I've already told you, you want to take some character inputs, then you have to use get character. If you want to put that character as an output over there. Now, one thing very important, this put character is having a return type int. Why int? Because characters are always stored as ASCII values, and ASCII values are integers, 7-bit or 8-bit integers over there. So you are always going to have an integer value taking inside, and even you can do some arithmetics over there. You can change A to B by having just plus plus over there. We just did in the part 1 as well. So this get character and put character are being used over there, and this is exactly the same thing, reading the string character. So every time now you are going to take some string input from the user, please always use either the get character or either use fgets over here. Then the next thing, the last two things for this part, which is the sprintf over there. Now here, this works just like the printf, but stores inside the string. Up till now, you are using printf to print on the monitor or the output device, whichever you are using it. Now here, this is going to store inside the string. The format or the specification is exactly the same thing. Here you have int sprintf character. This is the pointer to that array, okay, in which you are going to store it. So here, this will be a pointer to that array over there. That's why it is star. Then you have the constant character format and then dot dot. What does dot 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 mean? Dot dot here means that now you can have different strings or different integers being added over there. For example, let's see this example over there. I have a variable character array, which is s name. The size is 80. Then I have integer age is equal to 20, double GPA is equal to 3.75. So I have two variables over there. Now, I want to put something inside S over there, which is going to be a character array. I'm going to deal it as a string over there. So sprintf S is that array, which is going to be using it. And then I have inside it the strings over there, and here I'm using age percentage d. For percentage d, I'm going to put here age. That's why I have the age over there, and then I have percentage 0.2f, so 3.75 will be there. So s now contains age 20, GPA 3.75. And now when you have formulated everything inside that array as a string, now you can just print it as using your printf statement. Now, instead of taking the value from the array and taking, okay, where is that one thing? Easy way out. You want to present your data in some printable form, store it inside a character array as a string over there using the sprintf. Sprintf stores inside the array. Here S stands for that string, you can call it. A character array stored as a string over there. So this is sprintf. So this is going to get building strings for display, logging, or file output. Now, since this is just like an output over there, now you can print it inside a file as well. Inside, we will do this one in chapter number 11 for the file. But here, in case you just want to printing it on the monitor, you can use it by using this thing. Rest, everything is exactly the same. This is nothing fancy. Just like printf statement you have been using percentage %d and all that, everything remains the same. The only thing changed, the first thing, the first parameter is the array, which is going to store that all text. Okay? It's not going to be printed to the output of your monitor. It's going to be just plain. Similarly, you have scanf, and then now you have scanf. So this is going to read from the string. So now you are going to read from the string. Same thing, you have scanf, and inside scanf you have const character str. So you are going to read from a pointer to an array, which is actually going to be a string in this case over here. And then the same thing, you can have different parameters added over there. Over here, you can see now scanf, you are going to read from data. You are going to read from data over here, and inside data you have 25 space 87.5. So everything which is going to be stored over there with spaces, 25 will be read as d, 87.5 will be read as lf. Lf stands for long float. Lf stands for, f stands for float, lf stands for long float. And when you have done this thing inside data, you have the age and score. Now here you are not taking the input. Remember, scanf was taking the input from user. Scanf is taking the input from array. So when you have supposedly the data inside the array over there, that is age over there, from here you can take the input for variables inside this case. So this is just the opposite. So these scanf and sprintf, they are just the opposite of it. One stores inside the array, the other one takes the input from the array, and it's parsing the data. The word parsing means converting it into its readable form or usable form. So it's taking the data 25, storing it inside it from files of formatted strings over there. For example, let's just see one example over here. Examples are there. Please remember, when if I'm missing the examples, does not mean that they don't have to be done. I'm just skipping them for your to do. And over here, you can see, let me just go through this example. This is sprintf. Yes, this is sprintf over there. You can see over here, int x is equal to 0, double y is equal to 0. And here you are sprinting fs over there. And if I just run this one, let's say, run this one, you can see enter integer and double. Let's say I entered 2 and I have 4.5. So you can see the formatted output stored in array s is integer 2 double 4.50. So you can see the formatted output stored in array s is, and this percentage s and s. So s is now a variable, sorry, an array in which the data is being stored or printed, and then you can print it inside a file, you can print it on a monitor or something like that. Similarly, there is this scanf, and in this scanf, you can see now this is 312, there is 98, you have 87.375. So 312 will be going inside X because the first thing is percentage D. 98. Now let's see what happens over here. Now this is very tricky over there. What has happened? I've changed this example for you. 312 will be going inside X because this is the first thing inside it. Then you have 98. Now, next thing is long float, LF. Technically, if I have, let's say I have just 87.375. So Y will be having 87.375. And if I just run it, you can see now integer is 312 and double is 87.375 by using this printf statement, or you can have this something. Now here, just to give it something, let's say I've added some text because it's a string. Sorry. And I just run this thing, it's 000. So this is again a limitation on this function. What means that the data has to be only numeric, then afterwards it can. And supposedly there's something like 98.23 with space, it will take the second 98.33 in Y. And if I run this one, this will be 98.340. So these functions have some limitations, just like the function we just did in this part, that was 90 str2d or str2 L or str to ul, and all these functions have some limitations. So if your string or character array, they have some data in some specified format, then you can use them. Otherwise, you can't use them over there. Then we will talk about this one, I guess, later on, because this is about the string copy over there. I hope so. You have gone through this one and just go through this self check questions over there in the last one, which means which function print characters and return is as an integer. Yes. What's the answer? Of course, it's not going to be get character. it's not going to be, it prints the character. It's print the characters and returns it as an integer. So this is simple puts, I guess, and the sorry, put character. Sorry. Puts is just going to remain a string over there. That is going to be put character over there. Sorry about this one. So this is going to be put character is going to be the answer for this question. Then another question over there. Get character returns a character. No, it takes the input from the user. It does not return a character. It returns an int to support the end of file indicator, or actually the line over there. It takes it the character from the input or keyboard over there. That was the get character function, which we have used over here in this function also. I showed you this function over there. Uh, this function that was get character over there, and this is going to run up till it's a line over there. So it takes the end of file over there, which means it is going to take the end of file indicator, that is -1. I will talk about this end of file indicator in chapter number 11 in detail, because up till now you have been writing everything on your monitor. In chapter number 11, you will be having a file stream, and you are going to output everything inside your file. You are going to generate files from your data, whatever is going to be input from your user or whatever you want. Next part, we are going to talk about some string handling. Up till now, we have different types of functions discussed in part 1 and part 2. We have talked about string to that double, string to long, string to ultra long, or checking which are functions or not, converting to uppercase or lowercase. Now, strictly string handling library, which is called as string.h inside that one. And there will be functions such as string copy or string n copy, which means how many number of digits you want to copy, or how many number of alphabets you want to copy from that string over there, or catenate over there, which means joining the two, or the compare statement, or the search statement, or the length over there. The very simple statements, you already have used them inside your lab number 9, I guess, over there. So they should not be that difficult for you. So we will talk them in part number 3, and in this string.h library, this will be part 3. I hope you have learned something in this part 2. Please kindly go through this one, all the examples, specifically the examples over there, and try to now use fgets and try to use get character whenever you are taking an input, specifically character or string inputs from the user. Thank you, and Allah Hafiz.